We know when I'm talking about a quadratic equation, what is a quadratic?
X squared plus b squared equal,
Ax squared plus bx plus c.
Yeah, you know what I was trying to say.
Okay. So what we're going to try to do is factor those so we can use the zero factor property. And the zero factor property says if you have two complex numbers, so remember a complex number might have an I, but it doesn't have to, multiply together to equal 0, then one of those numbers must be 0. Or they could both be 0. So let's solve these equations. On A, what will we need to do to be able to solve this? Right, we have to get it equal to 0 first. If it's not equal to 0, we're not going to be able to solve it. So we add our x, subtract the 12, and then what do we do? So we're just factoring, because it's a 1x squared, we can do shortcut, just straight into our two parentheses. So we have an x and an x. What multiplies to negative 12 and adds to positive 1? Okay, so now we have two things multiplied equal to 0. So now it's set up for the zero factor property. So you basically set each of these equal to 0. So we get negative 4 and positive 3. Because it's a quadratic, how many answers should we get every time? 2. You have an x squared, so we should be getting 2 answers. Any questions on that one? What about B? Mm-hmm. So it's already set equal to 0. That means we need to factor. So the question is, how would I factor that? It's not a standard quadratic with 3 terms. It's missing the constant term. So square roots would work fine if that 9 didn't have an x with it, and you could move it over to the other side and then square root. What else? Yeah, remember the first step to factoring is always to look for a GCF. They both have an x, so you could take that x out. You have x minus 9. You have two things multiplied equal to 0. So we set each one to 0. So x equals 0, or x minus 9 equals 0. We get 0 and positive 9 for our answers. Is it possible to check these? Yeah, always. You can plug these back into your original equation and they will work. So if you're not sure, take the time and do that. Any questions so far? Why don't you guys try C for me? So on this one, multiplies to 9 and adds to negative 6. What would that be? Okay. So most of you So like realize that these were the same. So you set it equal to 0 and you got x equals 3. That's partly correct. How many answers did I tell you we always get? 2. What are my 2 answers? 3 and 3. We got the same answer twice. The shortcut for that, we call it a multiplicity. We put 3m for multiplicity and 2. That means 3 is an answer 2 different times. We will use that a lot when we get into higher polynomials, not just quadratics, when we're talking about cubics and things like that. We'll see that that multiplicity changes how the graph looks. So it is very important that you don't just ignore it. So you might need to make yourself a note. Repeated solutions are called multiplicities. What's the first step to solving this? And I want to write it in decreasing order, so I want my squared term, then I'm going to put the minus 12x, and then I'll have the plus 9. Alright, what do we have to do to be able to factor this? So this gives me x squared minus 12x plus 36. So that would go to, what multiplies to 36 and adds to negative 12? What do I do now? So 6 over 4 reduces to 3 over 2. So 2x minus 3 times 2x minus 3. Okay, we set those to 0. Add our 3 and divide by 2 and we get 3 halves. M2, multiplicity of 2. It was a solution 2 different times. Are there any questions about solving these by factor? We've done factoring already this year, and you did this last year, so it's really just taking our factoring that we did at the beginning of the year and adding the one more step where you set it equal to 0 at the end. Let's look at E. How could I solve this? Right. I don't really need to factor on this. The difference is that we only have one x on this. You know, if you look back my previous examples, I had an x squared and an x squared and x on all of these. And that's why we had to use factoring to solve them. This one's different because I have an x squared, but I don't have a term with just an x. So all we really have to do is get x by itself. So the opposite of a square is a square root. So we're doing what's called the square root method. You add a square root to each side. Now anytime you add a square root in a problem, what do you have to do?
Plus and minus.
So x is positive and negative square root of 5. And that's both of my answers. Positive square root of 5 and negative square root of 5. F. There are actually a couple different ways to solve this one. What are your thoughts? So like multiply it all out, is that what you're saying? Okay. So let's try that approach. So order of operations, would you have to square or multiply by 3 first? Square it. Okay. So now we multiply, so that's x squared minus 4x plus 4. Distribute the 3x squared. What would you do now?
Oh no, you can take out a.
Okay. So we subtract over the 48 to get it equal to 0. Then we need to look, everything is divisible by 3, so we can factor out the 3. Okay, since it's now 1x squared, we can do a shortcut. What multiplies to negative 12 and adds to negative 4?
6 and 2.
So if we go to set these equal to 0, we really have 3 things multiplied this time. If I set each of them equal to 0, can 3 ever equal 0? No, so that doesn't give me any answers. If I add up my 6, I get a positive 6. Subtract my 2 and I get negative 2. So 6 and negative 2 are my answers. Are there any other ways I could have done this?
Could you have divided those 3?
Alright, so let's talk about the other option. This worked, we got the answer, and just like all the others, we could check it if we plug it back in. The other suggestion we had, so you can just do this out to the side if you want. At the very beginning, are both sides divisible by 3? Let's cancel. So I have an x minus 2 squared equals 16. What could you do now?
Square x minus 2.
Okay, you could multiply this all out and set it equal to 0. Or we could take the square root. We only have x in one spot, so if I were trying to get that by itself, we could do the square root method. If you add a square root, you also have to do so x minus 2 equals plus or minus the square root of 16 is 4. And then we need to add 2. Right, this is sometimes the step where people make a mistake. They want to write x equals plus or minus 6 because 4 plus 2 is 6. Is that the same answer we got last time? No. What this means, yeah, you have 2 plus or minus 4. 2 plus 4 is 6. 2 minus 4 is negative 2. So my two answers are 6 and negative 2. Right, so this one we had a couple options. We could multiply it all out and factor, or we could have done the square root method. Any questions on that one? I want you guys to try a couple. So did you multiply this out or do the square root method? If we do that, we have to do plus and minus. So x minus 1 equals plus or minus the square root of 4 is 2. Just as a side note, if this were something like an 8, you would have to break it down and make it plus or minus 2 radical 2. So that's okay if that happens. So if we add our 1 over, we get 1 plus or minus 2. because those are like terms, we can finish it. So 1 plus 2, 1 minus 2, questions on that one? Next one. And when you do the square root of a negative, what do you get? So the square root of 49 is 7, so we get plus or minus 7i. And looks like we did pretty well on that one. Any issues at all? Okay, so what we're going to do, tomorrow we are going to solve by completing the square. It's a longer process, so I want you to go ahead and write down the process in your notes today. I'm not going to do any examples on it until tomorrow. So write this down. Once you have that down in your notes, you can start the homework, which is a Math Excel assignment. Okay? So there's your class